M1 and M2. And suddenly I set them off. They start spinning with the same angular speed, omega. Now, of course, that doesn't mean the same velocity. Why? Because it's going to appear like they're bound by a rod that goes directly through their center of mass. And their center of mass is, of course, much closer to the more heavy object than to the less heavy object. So, let's look at the angular momentums of each of these guys. So, the total angular momentum is the sum of the two individual angular momentums. The first one is I1 omega, and the second one is I2 omega. They have the same angular velocity, otherwise they would eventually bump into each other and our system would be ruined. So, we have this, right? Now, this is going to look more like, for point masses, technically we're dealing with balls, so I guess we'll go with that instead. But no matter what, it's going to be some fraction. In the case of spheres, it's going to be half mr squared, so m1 r1 squared omega plus half m2 r2 squared omega. Okay, so what is r1 and what is r2 in relationship to one another? Well, let's think about it. That this guy is at the origin, and m2 is on somewhere on the x-axis, right? So then we already know that the coordinate position of the center of mass is determined by this formula, where these represent the position vectors of each mass. But if this is 0, then this also goes to 0, and we just get this guy right over here. So that means that the magnitude of this, which is more actually like this constant times the magnitude of this, is equal to the magnitude of R1. And similarly, you can guess that R2 can be equal to this. Did I really just do that? Okay, so now what do we do? Well, the natural move is to divide them. What does that give us? Well, this is going to give us m2 over m1 times what? R2 over, wait a second. No, that's not. So, wait, oh crap, I'm tweaking out again. So, this gives us m1 plus m2, r1 is equal to m2, r2, right? And then, this similarly justifies m1 plus m2, r2 is equal to m1, r1. Okay, so this is m1, r1, which looks suspiciously familiar, plus m2, r1 is equal to m2, r2. Okay, so now we plug this guy in, and we get m1, r2 plus m2, r2, which looks suspiciously familiar, plus m2, r1 is equal to m2, r2. So we get the opportunity to cancel these out, and we finally notice that m1 over m2 is equal to the magnitude of r2 over the magnitude of r1, which should be pretty apparent from the diagram, right? I mean, the bigger m2 is, the smaller this distance gets. So this guy's nice. Now, I guess it should be implied that this is this, this is this, but anyhow, what do we do about this? Well, here's what we're going to do. We're going to show that L1 is actually equal to this fraction of L, where this is the total mass. L2 is going to be this fraction. Of course, they add up to just L, right? So, how do we go about doing that? Well, let's think about what L1 is. L is equal to what? Half m1 r1 squared plus half m2 r2 squared multiplied by a giant omega on the outside, right? So now, here's what we're going to do. We are going to use this formula, and we now realize that R2 is equal to M1 R1 over M2, which means that what happens when we square it is just going to be half M1 R1 squared plus half M2 multiplied by what? M1 R1 over M2 squared omega. So that's just equal to what? Half times M1 R1 squared plus M1 over M1 squared over M2 R1 squared omega. And that's when it becomes apparent that this is equal to half M1 plus M1, well, let's just factor it out and go full mask off. 1 plus M1 over M2 multiplied by M1 R1 squared omega, which means this is literally just L1, which is this whole part, multiplied by M2 plus M1, which is M over M2. Genius. So L is equal to L1, wait, I am general. So L, well, yeah, I think this sort of made sense from the beginning because, of course, M2 is less than M, and so L1 is less than L, which means obviously the fraction should be this way instead of the other way around, which would imply L1 is greater than L. Okay, aside over, L is just equal to L1 times M over M2, which means that L1 is equal to M2 over ML. And so L2 is equal to L minus L1, which is equal to what? It's equal to L minus M2 over M1 plus M2L, which is just equal to M1 over M1 plus M2 is ML.